Our first speaker is just my favorite person in the whole world, Dr. Julie Urban. And like she said, she's been with us since the very beginning. I have just enjoyed working with you so much. I always take a breath in when she calls me and she says, Dana, they're doing something different. I'm like, oh, I don't want to hear that part. But again, she's right on it and gets her team gathered and gets them. They all work so very, very hard with all the different projects running. So our first speaker this morning is Dr. Julie Urban.
Thanks, everyone. Thank you, Dana. That was lovely. All right, so you're gonna crawl into Julie's head this morning. I'm sorry, it's a little dark in there. Okay, it's safe, as far as you know. Okay, and so I'm going to present to you on some data, doing like a head-to-head comparison of female reproductive development in North Carolina versus Pennsylvania. And so just to give you some background of like what we were thinking or what I was thinking is that, for those of you who are, here or attended virtually yesterday and saw Dennis's presentation, one of the things like rattling around in my head a lot last summer as we were finishing up were the results of this paper. And so I think Dennis did a great job talking about this, but kind of hitting home the highlights because he had to hurry on the end. Basically what we found in this and, doing the trapping, we found, every life stage on red maple, like all through the year. And, we're able to look at accumulated degree days using January 1st as a biofix, and that estimated the timing of nymphs great. And we were able to record what a lot of us have seen anyway, which is this late season movement. We have the emergence of the adults, but also this movement of males out first, followed by females, and then egg deposition. And so we were able to trap that, but the models like fell apart at that point. But if you instead used the appearance of the first adult as your biofix, and so essentially start, once the first adult comes out, start counting your degree days from there, that's a really good predictor of that late season movement and egg deposition, which kind of from a practical perspective simplifies things, right? If you're out there, your folks are trying to figure out when do I need to put the traps out, that kind of thing. Once you hear about the first adult, start counting from there. And then basically we saw that the late adult activity and egg mass deposition seemed to be triggered by an environmental cue. It didn't matter we had the cool year and the warmer year, the degree day accumulations like kind of differed when they laid eggs, but it made sense in light of the equinox, okay? So picking up from there, then what Dennis was showing you is that was our map of the growing degree days that can be accumulated throughout the whole year in the Northeastern US. And so the question then is so basically getting back into my head, this came up in like at least 3 different conversations yesterday. This fulgurid is weird, okay? And so one of the things that we're all kind of puzzling about is that, okay, lanternflies are one of 14 families of plant hoppers, the lanternfly family. There's 500 species, whatever. They're mostly tropically distributed. This one's weird being so temperate or having such like being able to occur in a pretty cool range. But we also don't know its full range well. Matt made that point very well, right? And so the other thing that's super, super, super weird is that, okay, we don't have great natural history data for fulgurids, but we do for a lot of other plant hoppers. There's rice pests, there's all these things. Every freaking plant hopper known to science has 5 nymphal instars, right? This one has 4, right? And so part of the weird thing with this is like, okay, we see, and again, we don't know much about the natural history of other fulgurids. Great. Some of them are bivoltine that are in the Southeastern US. We know a couple, but it's like, okay, this thing's a freak show in at least like here, Harrisburg area. it emerges as an adult in end of July, and it doesn't start mating until September and laying eggs till September, October. So that's a super long time for an insect to have to live before it reproduces. And so it's like, is that extended adult period like what would have been the 5th instar plus, like what's going on there? Do we have a protracted 4th instar? Like what's really going on? And so the question has been, because you have that late time period and it takes so long, maybe, it's not the tolerance of the eggs to temperature extremes that's going to limit their distribution. Maybe it's where you have warm enough days to get to that adult period or to get to the egg laying that's going to be your limit. Okay. And so in that paper, it said, okay, where are there enough growing degree days for adults to emerge? And then where are there enough growing degree days? Where's it warm enough to get to that egg stage? And so this is what Dennis kind of blew through at the end. And you said, okay, we had slight differences in terms of adult development on Tree of Heaven versus red maple, but pretty much, and that shows you like the percentage of the population that would be warm enough to get to adult emergence. And you could see, well, on nuts, not many places are off the table, right? But that's to get to the adult. And so notice though, in that paper, if you've looked at it, we didn't make a comparable map for percentage of female egg deposition in that paper. I'm doing the internal dissections, right? To really see when they're mature. Because as I like to think, just because she didn't lay doesn't mean she couldn't lay, right? And so that's kind of where we're going. So with that map, if we look at that and we say, okay, how many degree days accumulated before in 2019 and 2020, before we saw the first egg mass, and first egg mass in 2019 was, that we saw, was laid September 28th. The 2020 was September 25th. And so first mass was like 1,700 one year, 1,500 the other year. Mean egg mass, when most of them got dropped, was a little bit later. And so we say, like, okay, if 1,500 and lower is, not long enough, that looks a little bit better, right? There's fewer places, but does it drop off a cliff up there at the northern range? No. I mean, does this explain they're doing great in Scranton? I don't know exactly where those pockets are, but we need more to it. And so I've been thinking about this northern end of the range, and I certainly want to collect more. I've talked with Jen, I want to see what egg masses look like, right? And females look like in the north. But then I heard, we found out they're in North Carolina. And so it's like, what's happening at the southern end of the range, right? And from that evolutionary trade-off, like if it takes so long to get to the adult, like that seems disadvantageous. Where do they like get it back? What's the trade-off? What's the benefit? Okay. And so I was like, all right, I want to do a head-to-head comparison here. But the other thing rattling around in this fool's head is that people do a great job, like Melody Keena and Tracy Lesky, rearing lanternflies in captivity. They've got it down. It's really tough to do because you always have to feed the beast. You have to trade out these trees. There's like the aeropod, like some cool things going on. But like, I'm on some of these papers where I've been dissecting, like, from these studies that are cage reared to see how many get to maturity. And I'm obsessed with yellow bellies, that. And so basically we measure I wanted an in the hand indicator of like kind of how well developed the female was or how developed. So we've taken images and we measure this area. This area is highly correlated with body mass. But basically what this is showing you is that, boy, you get really big bellies in wild lanternfly. They're left to forage, and they tend not to be as fit in lab reared populations. Again, limited data, I want more data there. And so I'm thinking, well, probably what our lab should do, and if we've shown this a little bit before, but like, I don't want to rear them. I don't care. We can rear them long enough to get them to do Holly's experiments and do what we need to do. But I want to look at the wild populations and get fitness measures, understand the baseline of what they're capable of doing. So I have 2 summers ago, my technician, Elena Gomez, led this work, and Tess, another technician, helped. They picked sites across Pennsylvania and said, okay, 1 week they're going to drive and go from State College, hit all of these sites out east, collect at least 20 bugs at the site, put them in their own pop-up containers on a Tree of Heaven plant, bring them back, measure the live mass, okay, stick them in the freezer. The next week they'd go west, and they alternated and did this from May until the bugs died out, November 7th, okay? So we have the live mass of all of these populations. Some of them they took off, you know, but we had at least 11 sites where we had data for that whole season. And so we're working now to take look at nutrient levels for fitness, carbohydrate, protein, lipid. And the idea here is that we want to use this as I want to use this as a baseline for doing these kinds of comparisons. You know, how do in the northern range and the southern range, how do they compare with this baseline, right? And so, road trip North Carolina, okay? And so talked to Greg. Oh, but let me show you this first because we're going to come back to it. And so basically for all of those populations, the ones that we got data from all year, this is how their mass from first instar to adults before they died off. You see it constantly increases over time, boatload of variability, right? But again, we see like our biggest population here is actually that's the Pitcairn site, okay? And so that's as of November 7th. They just kept getting bigger all year. Okay, so this is a good comparison now for what we're going to look at. So I talked to Greg and he put me in contact with the NC State folks. I'm dying to see what they're presenting later. Abby Ratcliffe and Kelly Oaten, and they said, sure, if you want to come and get some bugs, great, no problem. And so basically I did 2 collections within like a day or 2 apart in North Carolina, talked the husband into it. You like a road trip, right? Yeah. He's in education. And so sure, Kevin's awesome. And so anyway, August 19th, I went, you know, in Lewistown, collected 100 females, you know, put them in pop-up cages, took them back to my porch, measured the live mass of each of them and stuck them each in their own vial. Did the same thing then, boogied down to Kernersville. You guys did I told them that they've done a great job treating that site. I was able to get 100 females at one of the locations. They had 3 that they shared with me. But then I went back a month later. That time we did, you know, just the way the days fell in the week, went down to the Kernersville site and I was hard pressed to find bugs. I went to all 3 locations, you know, got 17 bugs, but then like kind of looked around it again. It was trying to be fast. I didn't really coordinate things. I was able to get 42 females and then came back and got the 100 females in Lewistown. And then just because of what I saw and how big they were in North Carolina, I went back over a month later to get them again in Pennsylvania to see if they ever caught up, right? I didn't go back to Kernersville because you destroyed that population, I think, right? And so anyway, for each of these, recorded the live mass. Everybody had their own vial. And so for data here, I'm still dissecting these, but it's like 10 dissected per. And so basically doing we have a rating sheet. It was published in some of Laura Nixon's work. And so basically you see like, oh, the back. Basically you see early stage ovaries are like little, like look like ovarials on a plant, my students tell me. And so basically little flower buds, and then the eggs as they mature, you get like beads on a string, right? And then you see the mature eggs, and we'll talk about down here, they don't develop all of their eggs at once. Okay, so what did I see in terms of live mass? Okay, bugs in the hand tell the story like, oh boy, the girls were big down in North Carolina. And so you see in terms of just their mass, it's like the range, you see essentially everybody was a little bit larger. And from a growing degree day perspective, let's add that here, not too surprising. Okay, so they were ahead in that first collection, but the second collection, holy cow, they're huge, right? Absolutely freaking huge. And then here, they really never caught up even a month later in Lewistown. And so, okay, what did it look like when okay, so now it's like, well, I got the trees, I got my bugs next to the lows in Lewistown, which are hammered, right? So like maybe those bugs aren't fit, you know, and so here, this is where now we have this baseline. What does it look like compared to all of these sites together? And so if we do that, we see that, oh my, that Yeah, they really are big. So the mean female mass in North Carolina in September was 0.58, bigger than the mean of the largest population we saw the year before. And, in King of Prussia, which was like 0.5. So by November, they only got to average of 0.5 in Pennsylvania versus that big there, that early on. And then even if you look at the range, you have one up here that's like almost 0.8, which is huge. You have one here that's 0.8. Again, even with that kind of extreme, like basically that variation kind of matches what you see in that late season. So, okay, what do they look like inside? And so the first collection event, nobody was mated, and they were a little farther ahead in terms of they were at the beads on a string stage in terms of their ovaries. The next one was what I was really kind of shocked about. Everybody was mated in North Carolina, and 8 had mature eggs and some undeveloped tissue. In terms of Pennsylvania, it looked like what I expect. They had some ovary development, no mating. And what I mean with some reproductive, so basically they don't mature all their eggs at one time. These are obviously mature eggs. I'm making you look at bug guts. And those little, like, those are the beads on a string that aren't developed, okay? And so we know from Tracy's work, she's reported a mean 2.12 or something, just over 2 egg masses per female in her colony. Melody Keena, when I went to ESA to present this, saw her on the street, she has a few females that have laid 4 egg masses, okay? And so basically my take there is that they're ready to go and they can keep going, right? If you see that. And so on the, they, in terms of maturation, they kind of caught up in Pennsylvania. 9 were mated. And so again, they had potentially maybe they laid egg masses already, maybe, again, more tissue that they could go, or more tissue so they could lay other egg masses. But overall, just like these conclusions, they're bigger by mid-September, greater body mass of females in Pennsylvania, even compared to those at the end of the season in Pennsylvania. Does this mean in southern regions? I kind of am afraid it does, but we'll find out. Does this mean that female eggs will lay, like, what are they going to do with all of that mess? Are they going to lay more eggs per clutch? Are they going to put more lipid or resources in it so they lay more fit eggs? Even if the population, the laying is cued by some external date or by some external environmental cue, they laid slightly earlier and you have a bigger growing season window, right? And so are they going to be able to lay more egg masses, or even if they're not, I think they might, but lay more fit egg masses? And overall, like, kind of, I'm thinking of it in terms of evolutionary trade-off, be more successful in the South, right? And so I'm really interested to hear the stuff that Abby and Kelly have to present. Their first egg mass that they observed was September 3rd. So again, seems to be triggered by day length or something that's kind of late compared to how they looked inside. They were checking their traps, as I understood it, every 2 weeks. And so basically it could have been even 2 weeks before that. I'm not really sure, but I don't know what's going to happen in the South, but I'm really interested to see what happens in terms of fitness of these southern populations. So with that, I think that's all I have. So I don't know if I have time for questions. And thank you for APHIS and PDA and SCRI funding. Thank you.
I was just wondering, Julie, I mean, we've talked about this before too, when you're showing the lab versus the wild. I mean, you think a lot of that's because most of the lab colonies are just on 2 hosts primarily, and wild, yeah, can feed on multiple. Like we were talking about, like, nutritional quality of the feed.
Yeah, I think that's exactly it. I think that when when they're being fed a potted plant and only like 1 or 2 food sources, I think that's limited. Certainly those are really important studies, and it's I mean, that's some really important work coming out of it. But in terms of animals being able to forage with whatever they want. You know, we were talking about, and I think there's just going to be more fit. So the whole idea of, you know, what is the advantage of a polyphagous diet? Well, if you're feeding on Ailanthus or something that has a toxin to it, you know, the animal has to still process it and sequester it or do whatever. And so you feed on a wide range of things and that could dilute it. You know, I think that there's all sorts of reasons that it's beneficial to feed on a lot of different things. So yeah, I think that that's why the wild populations do so much better.
Did I catch it right that the North Carolina populations in your dissections had mature eggs, but had not really started laying? Am I getting that right?
Yes. And so this is where I just did that run and collect thing, right? And so so basically Abby Ratcliffe is a postdoc from NC State who went there. They're presenting later today. But what she reported in like emails to me was that they observed their first egg mass because they had Phil's traps out, right? And the crew over here, they were really looking as well, but they saw the first one September 13th. So it doesn't mean they couldn't have laid it earlier up in a tree or that kind of thing. But at least the first one that someone observationally confirmed was that.
Speculation on sort of the advantage to kind of not laying eggs as soon as you can?
I don't know, right? That's what's weird about it. And so, I mean, it could be, Dennis kind of mentioned this, but is there a potential in their native range, like a potential parasitoid or some other enemy, right? That it's evading that phenology. Could be, but I don't know. I think that's a weird question. And the other thing that like we've talked about a lot is, could they egg dump? Right? Could they, you know, is it the case that like, oh, if you get a cold snap, like I'm holding them, but I got a cold snap and I'm going to go. And you have data that shows the egg masses more accumulate over time, that it's like a steady thing, at least in Pennsylvania. But I don't know. But I'm really, I think about that a lot. Yeah. All right. Cool. Thanks.
Right, up next to present, we have Brian Walsh with the Penn State Extension.
So good morning. I'm going to just talk a little bit about the update with the insecticide impregnated nets that we've been doing. I think most of you have seen some of this stuff already before. I just want to go over a couple of different things. The trap sensitivity for monitoring, and just for fun, the dispersing adult sex ratios, to touch on what Dennis and Julie have already talked about. One thing, these are pole traps that we developed, and I've gotten better at identifying the regurgitated pellets of birds of prey. They really like them, and they'll puke them up, and we catch them in our nets. So good times. The insecticidal netting, this is a deltamethrin netting that is used in anti-malarial bed nets around the world. And we started working with this in 2019 and found it's incredibly effective against lanternflies. And for those of you that have seen before, we started with just trying netting on a pole, found that they would make contact with it, they'd launch off the pole and then go out and die in the nursery. And then we'd be trying to find them out in these little conifer plants, and it's not fun. So we found a way to keep them on top longer. And then that developed into the pole trap that you see there on the right. And then at the bottom, you can see we developed a catch net that is off the ground. We had a lot of predation. There's a lot of wetness when you use ground tarps. And alluded to, was talking about it yesterday, your frequency of intervals of how bad that smell gets over time. These are really nice. If anyone's interested, they run about $83, $85 a piece to manufacture, really easy to do. And we wound up using them on utility poles, and I'll show you why it was necessary to do so. But you know, if you're doing this with ground tarps, and Liz can attest, she would take bags of these home and spread them out in her parents' living room and identify them out. So I apologize to Liz's mom that it took that long to find a way to keep them dry. The other benefit of that is a lot less predation, so from especially snails. with this, we have multiple years now in the nursery where we started all with this in 2019. We did really well. 8 poles, we killed over 12,000 insects just from their contact with the poles. They're simply attracted to that vertical shape. We've all seen the reports about silos, skyscrapers. They're attracted to that vertical shape. They'll go to it. If we can keep them on the netting for as long as 1 whole minute, we found within 96 hours, almost 100% mortality. And that's reasonable. We've tested a bunch of other different nets that were not as successful, different compounds in them. With our data that we have for 4 years on that site, it works well. Total that we killed out of there, what happened was the population dropped. And so we had a lot the first year, less. And that's a really good thing for those of you who are going to go through this. We've seen consistent decline after that worst of the boom. Not 100%. Grapes are still an issue. They still come into grapes, especially late season. They will find grapes. But overall in the landscape, the numbers went down, but we killed 22,000 adults that we trapped out without having to spray an ounce of insecticide out into the environment. That's pretty cool. With that, we did try other materials. Some of the nets were very effective, but had no UV treating, and so they were in tatters by the end of the season. We had poles installed at the Berks campus, and we've tested different configurations. And one product really stands out, and that's the delta methrin. With our traps, with these traps, we had very little non-target catch. Brown marmorated stink bug was the #1 bycatch, which nobody's going to cry about, right? #2 would probably be far and away wasps, different wasp species, yellow jackets that are scavenging on our corpses. And so, they would then get in just enough delta methrin that they would die there too. But in that, you can see that of the bycatch that we cared about, it was less than 2%, just over 1.5%. So really, I think an environmentally good way of doing this. We went and then partnered with Pico Energy in Philadelphia. We wanted to see if we could use existing utility poles that are all over the place and use that attractant to get them in. And it turns out it doesn't work so good. There's too much background visual noise is what we think is going on. But you can also see with these catch nets, it's nice because they were up off the ground, didn't interfere with line of sight, that we wouldn't have any issues with PennDOT, and it also prevented people from throwing things in that we didn't want. Not that there's any needles or anything laying around in the port in Philly, but it worked out well. And just using a 6-foot step ladder, the nice thing is they unzip, you can reach in, scoop them out, and you have your stuff. It takes just a few minutes to sample, bag it, take it with you. In those 8 traps that we put out that we were able to monitor, 2 of them we were never able to get access to once they were installed. That's a different story. Make sure you can get full access. It was really inconsistent. The first trap there you're looking at, it looks good. It's in the middle of nowhere. It's kind of above everything. Thought it would be good. We got 4. And the population in this site had been just through the roof the year before, crashed. And overall, the neighbors were telling us, yeah, they're just not here this year. So, of course, once we got there, once we got set up, well, the bugs left, as is the way it goes. This pole here, number 2, we had 15 on that one. There's a little bit of greenery around it. How far apart? You can see them both in that picture. That's how far apart they are. So there's something there that, 4 times as many and not a huge sample size. But then the third trap, this is out in the marshes just below Philadelphia International Airport. This trap through the season consistently caught the most. And what's really nuts about this is that the next one is 200 yards away. So what's the difference in 200 yards that we would go from 76 to 6? The best I can equate with is you see that there's some trees around. I think the further out you can be in the open away from other vertical stuff, maybe. The other traps there, very low populations in those locations, but every trap caught at least 1 lanternfly, which is cool, right? So as a monitoring, we got positive hits on adults, and adults are difficult to trap. As far as the delta methrin in those nets, with 3 years exposure, it dropped, just about a quarter of what it originally started with. So we know this netting is very long lasting. The way that they make this, that Vestergaard manufactures it, they extrude the yarns with the delta methrin in the yarn. And as it breaks down, a little bit more is exposed and a little bit more is exposed, but very little migrates off the net. So we don't have to worry about the delta methrin being washing out into a sensitive site. So what's next for this project is Lake Erie, and you're going to hear all about the Lake Erie concept this afternoon and the grape growing region there, because lanternfly is all around the corners of it. What it looks like there is a lot closer to what we would look like in the nursery. We have a lot of low terrain features with all the grapes. If we can put poles up there, they'll stand out. We think we can get good success, good draw on them. The railroad tracks that run through there are concerned. Everything that's along there, you can see it is main line with grapes immediately adjacent to. So we've already started talking with some of the farmers there, and hopefully this is where we're gonna go with this. The unfortunate thing with the netting, and this is, they'll touch on this this afternoon. The unfortunate thing about the netting is in 2021, the manufacturer canceled the registration. And so now we're working with them to get it back registered through the EPA again. And it looks promising, but we don't have a legal labeled that we can put these traps out or say to you guys, try this, right, at this point. But hopefully we're getting there. Next thing I want to talk about was the sensitivity of trapping. And Ann talked a bunch about this yesterday, and I just want to qualify for Ann. We talked about it afterwards. What she was saying in her head about maples not being a suitable host, what she meant was through the year for nips. Okay, and as Julie and Dennis have said, we see them coming back as adults, definitely come to maples in the fall. So that's just a quick qualifier for, because I heard, we were talking to a couple people yesterday, and they said, we thought red maples were good. They are good in the fall. They move back in the fall, and just didn't express that explicitly. But what I wanted to do was just look at how sensitive these three different trap types are for catching the nymphs that are there. And my concern is for the states that are using these for monitoring, where they're putting traps out in the hopes of catching what might be there in a high-risk area, what's the most sensitive to catching nymphs? And so we tested just sticky band with a wire mesh over it, just as a bird protection. We tested the circle traps, and the other one was bug barrier, which is, you can see here, it's a commercial product with a sticky that faces inwards to protect from bycatch. And the design on this was simply 27 trees. We broke it out and grouped by DBH to try and account for the attractiveness of the individual trees, and they're all lanthus on one site. And we broke it out, and then what we did was we put a second trap above, which was only sticky bands, just the straight up fly paper and screen. And what we wanted to see was how many went past the first trap and got to the second trap. And when we did this, and this is Dr. Joe Keller, who is just the greatest at doing these things with the stats and making it that I can understand it. But you can see each week going across the bottom, each vertical line represents a sampling week. And I should say we could only do 24 hours because our bands would fill up if we left them over 24 hours. There were so many on the site, then they would saturate, and that's not what we wanted to know. But you can see where the dot placement is as a proportion of how many were trapped off that tree. Where the dot is what percent were caught in the first trap. And anything above that was caught in the second trap. And by the circle size, you can see how many, it get bigger with more bugs, smaller with less bugs. And you can see that the bug barrier and the sticky band really perform the best and almost side by side. And as it comes to the ease of use, bug barrier, if you have the money, it's not a promotion of the product. It's just fast. It's easy to use. To do the pleating of the screens around sticky bands to keep the bycatch out. You would think it'd be easier than it is, but a few people have proved that there's nothing idiot proof. And Douglas Adams, never underestimate the ingenuity of complete fools when you try and make something foolproof. But what we saw here is that the circle traps were consistently letting more by. And this is not an argument about what catches more. This is how many get by. When it came to total catch, those circle traps caught more. And like I said, we grouped these by DBH size so that we tried to block them. The biggest DBH got one of each. Next biggest DBH is one of each, right? And the circle traps did catch more. In the bycatch, very different from what Ann presented yesterday. Far and away, we got more bycatch in the circle traps. But when you look at that and break it down, the majority of that bycatch was ants, 2,500 on that site through the season. So if we don't really mind that the ants are getting trapped in there and we just worry about the spiders and then all other bycatch, bug barrier and the circle traps were about identical. The sticky bands caught a whole lot more. So whether it's because they color something, I don't know, but they did catch a whole lot more accidental bycatch. When Joe ran the statistics, it turned out the DBH was not a predictor of what was coming to, how many were coming to the trees. What was actually the predictor was how far in off the lawn edge. And so the closer to the lawn edge of the tree, the more insects they were catching. And this, we know this bug, it's an edge species. It moves back and forth and it moves a lot and it uses those lawn areas as much as it goes up and down trees. And so you don't need to go deep in the woods is what this is showing. And I would say it needs more data in different places, but all things considered, all the same species, it's not the biggest tree. It's the closeness to the edge that we caught the most on. And how did we do with the catching? Like what does it look like? Well, when we have the sticky band and sticky band, you can see the bottom one, how many made it up and then the bottom would be to the right. And you see the top one, there's nothing there. When we looked at the bug barrier, you know, there's a lot of bugs in that bug barrier, very few on the top band. When we look at the circle trap, we caught a lot, but so many made it by that you can see how many got caught in the second trap. And so strictly from a sensitivity point, I think the bug barrier sticky bands are more sensitive than the circle traps. In terms of how many can you catch, you can fill a band really quickly. Those circle traps can catch a whole lot more. They're two very different things. So with that, I forget why I put this back in here. So we'll skip that. We ended a little bit early. That's what I wanted to say. We ended a little bit early. The adults were just not being caught. And Ann was showing that too. They pulled it, I think, at the end of September, Kasha, right? And we had pretty much the same thing. The bugs are there. You can see them. They're just not getting caught in the traps. Plus, that hillside was just not fun to walk on anymore. It had so much honeydew and sooty mold. It was dangerous. It was slippery. And everything was getting beat up by the end of the season. But when we look at the overall catch, what we caught on there, we trapped out just under 80,000 with 27 trees and only one day a week, one 24-hour period a week. Holly took another 20,000 off that site. And we still ended up at the very end with, in our live counts at the bottom there, 800 on those 27 trees. So what impact did we have? We took 100,000 off a very small site, and there's still a lot there, and there's still eggs that were being deposited at the end. And I just wanted to point out that when you look at this, these numbers, you can see when we get to the adults being caught versus what we could see in the visual counts, this is not the way to do this for population estimation. Do your visual counts when you get to adults. If it's monitoring, you can't have somebody out there 24/7 that the traps are. So leave them up, see if you get lucky and catch something, but they're very good as adults of avoiding all types of traps. So the bug barriers and sticky bands just consistently more sensitive. In the low population densities, I would consider that more important than how many you can catch. DBH was not the predictor, it was the edge. It was the edge effect, and I think more should be investigated with that. And like I said, with that, we're good at catching nymphs. They're not the best at catching adults. And when the sticky bands were used with those barriers and with the bug barrier, we did not catch a single bird or mammal. And we also had other sites with these traps going. If you do it safely, it can be done. The problem is the public doesn't generally do it safely, so we don't recommend that they use sticky bands. And then this is just some fun stuff I threw in. At that nursery site where we developed the pull traps, you can see that we track by sex, and the blue is the males and the pink is the females. And the first year is the solid line when we had the highest number. And we got our install and going a little bit late on the adult season. It was the end of August when we first started. And we see that male population was just dominant. And then it started dropping, and where that crossover is, and you look at it by calendar day, it's the third week in September that crosses over. And the second year, you can see we had them going at the start of the adult season. Those males and females, early adults, tracked dead on. They were even until we started to see that dispersal on that broken blue line there. And where did they cross over? Almost perfectly in line with the year before. And as Julie was showing you, that's different in growing degree days, right? Same site, 2019 to 2020. And then we look at the third year, where do we see that crossover? It actually happened quite a bit later at the end of September, 2 weeks later, not tremendously different. The third year barely registers. Last year we had those polls up. Anyone want to guess how many total? Now, knowing that we did 12,000 the first year, anyone want to venture a guess how many bugs we caught on all 8 polls on that site last year? 5. So the populations, they do fluctuate quite a bit depending on the location. When we look at those ratios in Philadelphia, small sample size, 9 polls, not a lot caught, but still we see the end of September was where that female dispersal took off at. And unfortunately, that was all mostly on one poll, one location. Other studies we've done with insecticides where we track the sex ratios, where do we see it? This is Topton in Berks County. We see that fairly even male break, and then a little bit evened up, and then the females go end of September. End of September, it's that, what is that cue? And for us, I think it's something to do with day length equinox. Degree days, we'll find out more, but it's consistently year after year. In this site at the bottom, this was Meadowwood. We see the male dispersal, and they were absent on this site up till they started arriving in as adults. And then we see that female break out, end of September again. And just because it's lanternfly and it has to be this way, how consistent is it at this site where we were doing the trapping? It's not, right? Females never showed up. We stopped 2 weeks early, but this is the problem with lanternfly. Every time we start to make a rule, it makes a fool of us. And just because I love this picture, this tree died the year before. The homeowner told me it broke off in a storm in the winter. It was stone dead. And when I was there, there they are all over a stump. There's nothing there in that stump to eat. So what's the attractiveness? There's still more here that we're just not getting yet. So with that, thank you to a whole lot of people that top line and second line. Yeah, we'll cut it off at Julie Urban because she doesn't count rotten bugs for me. She does her own. But at that first group, they do an amazing amount of work in nasty spots where they get covered in honeydew. And Liz is in there for quite an amount of time. So any questions? Yep.
Hi. So you mentioned something about the circle traps not being great at catching adults.
Yeah.
So I have, we in New York have, I think actually it's happened in a couple of sites where the circle traps during the fall season fill up with adults.
Mhm.
And I was wondering, in your estimation, what does that mean about the population on that site?
I think you got a big population.
It must be
It could-
huge,
that'd be
right?
the-
Like if the trap is not very efficient at catching them, and every week that the bags would be completely full.
Are you doing visual counts to compare against when they're at the sites? Because that's the
It
first
was-
question. I
Well,
would
we
ask.
had it a few places, so we did have.
The trees were loaded. Yeah.
Yeah.
So if you're only
And-
catching 5%, 5% of 1,000 is still, filling a bag.
Right.
So,
So, okay, yeah, thank
Yeah.
you.
Any other questions? Jen's behind. Jen.
Thank you, Brian. That was great. And I don't know if this is the right place to ask this question, but maybe you do know. So you're talking about the males. Do they mate and die, or do they mate more than once? And what is that decline? Julie, I see you shaking your head.
That's a Julie question. You want to go? No.
So we're still working on it.
Julie
yeah?
says
Okay.
this is the wrong place. That's her answer.
Oh, yeah, I was just wondering, Brian, if you said they were commercially available, commercially purchased circle traps?
Not circle, those were commercially purchased and
Okay.
I inherited them from Kelly Hoover. So I don't know
Okay.
where they originally came from.
Oh, yeah, I was just wondering because they look different than what we have for the programs. I was just curious.
Yeah, I think they were Great Lakes originally.
Okay.
Yeah.
Brian, so that discrepancy that you saw between the total captures for the different styles of trap,
Mhm.
with the circle trap catching considerably more than the sticky bands, is that due partly just to the saturation of the sticky material, do you think? Because you said you were changing that out daily. I just wanted to
No,
clarify.
we would put the traps out for 24 hours and pull them. And we
Okay.
found at that rate, they wouldn't fill completely to saturation because once a band gets completely saturated, they'll walk right over their siblings and you're not
Yeah.
catching everything. What that was, I think, is the attractiveness of the individual tree. And so we know that certain trees are more attractive than others. And that's what we were trying to do with DBH, was trying to equate that and even it out. And it didn't work by DBH. So I think where we see more caught in those circle traps, those trees were just physically more attractive to the insects.
Pick the right tree.
Yeah, we were just trying to make all things even.
Great. Thank you
Yeah.
for the clarification.
Any other questions? Nope. Thank you.
I had kind
Oh,
of,
sorry, Kasha.
yes, I kind of just wanted to add something too. So, you're saying that the males were dispersing away from the trees. I just wanted to add that they're going into the vineyards and you see that exact same sex ratio difference where the males are mostly there in the beginning, then the females come and then they outweigh how many males are there. And then the males kind of start moving out, which is kind of interesting as well.
Yeah,
Just wanted to add
and
that.
I didn't mention what's kind of cool with the pole traps is there's no plant attraction. We're just intercepting flight. So this is just what's on the move at that time. So that's kind of cool. We're taking the plant effect out, mainly out of it.
Yeah. And I wanted,
Versus what Dennis was showing by species, movement from Melanthus to red maple. Hopefully what we're doing is catching what's moving at that time.
yeah. And I just wanted to add one more thing as well. So they are dispersing, but there's only such a small proportion of them that actually go into the vineyard, even if you have those woodlands right next to it. It seems like I can't quantify it as to how much it is, but at a lot of sites I tried to trap both in the vineyards and both in the wood plots. And it's crazy how the wood plot could still be filled and you have like such a small proportion, which still looks big for the grower, but it's only a fraction of the population in that area. So it's like really important to get like a huge view of what's happening.
Yeah. Yeah. Okay.
We do have online questions, but there are quite a number of them. There's 5 of them. And then Julie had one as well. So we're already past time a little bit. So I'm just asking if we could maybe move on. And if you
I
don't
can
have
answer
your
off the
computers
hub.
open,
Yep.
come out to my laptop and you guys can certainly answer them there.
Thank
Thank
you.
you.